Previously, we have learned equations. Let's look at example we talked about before. Say y equals 3x plus 2. This is called an equation because it has equal sign. But this equation has two variables. One is x, the other is y. As we discussed before, it has infinitely many solutions. Every pair, xy, becomes a point in a coordinate system or in a plane, and the infinite many points can form a straight line. So this is what we discussed before. But this time we're going to look at something a little similar, not exactly the same, but kind of similar. So functions. And what's a function? So the function, like this equation we have, I can also call this one a function. What's a function? A function usually, when we have it has what we call like a input, or you can call it independent variable. The formal name is independent variable. And then there is an output y. We can call it dependent variable. Because the reason we call it dependent variable is this value of y depends on what x is. So for example, if I pick 1 for x, 3 times 1 plus 2, y will be 5. And then if I pick 2 for x, 3 times 2 is 6, plus 2 is 8, y is 8. So every y value depends on what x value is. That's why we call y a dependent variable. And we call x independent because you can pick any number for x. So does not depend on anything. Right, so when we write down the functions, usually we use the first letter of function, the word function, and put the independent variable or the input in the parentheses instead of using a y. But actually y in this case is the same as our f of x, and keeping the right hand side. So this is we call it a function. And so it's kind of similar to equation, but a function is also equation, but equation may not be a function. So in this function, we have independent variable x, and so we can pick numbers for x. Say let x be 1. If x equals 1, and we can find the corresponding y. Previous we called it y, but now we don't call it y anymore. We call f of 1. So if we replacing x with 1, so we get f of 1. What's f of 1? So we're replacing x with 1. 3 times 1 plus 2 equals 5. And this is also similar to a vending machine. So we can kind of draw like a vending machine here, and we can put numbers into this machine. And what's the machine? The machine is the function. So we can write down the function here. F of x equals, maybe I just put 3x plus y here. 3x plus y. So this is our function, and something will come out. So the number you put in there will be your x for the value of x. So if you put a number 1 in there, it goes through this vending machine, because the vending machine, what this machine does is to do these two operations: multiply the number x by 3 and add 2 to it. So it's similar to what we did here. So when you put a 1 in there, you're gonna replace x with 1. You do 3 times 1 plus 2, that gives us a 5. But if you put 2 in there, and you're going to replace x with 2, so that gives us 3 times 2, 6, plus 2, 8. So that gives us an 8 there. And then if you put a 3 there, you're going to get a different number. 3 times 3 is 9, plus 2, that gives us 11. You can also put negative numbers. Say, if you put a negative 1 there, negative 1, 3 times negative 1 is negative 3, plus 2, that gives us a negative 1. So the output here, we call it output, and this is the input. Whatever you put in there you're going to get something out. You put a number in there, you get a number out. But the way when we do the questions, we don't really want to draw a vending machine. You can think of the function as a vending machine. But when we do the work, say if someone asks you to find f of -1, what does this mean? It just means, remember, the number in the parentheses means the value, it's the number for the input x. So it just tells you this x would be -1. So we're going to replace that x with -1. 3 times -1 plus 2. That gives us negative 3 plus 2. That's -1. So that's the answer. And previously we called this number y and this 5y. But now we just say this is the output of -1. Or it's the value we get when we replace x, when the independent variable x equal to -1. So similarly, we can find, say, find f of 0. That means we replace x with 0 in the function. This is the function we're working on. In this function, we replace x with 0. And keeping everything else, keeping that 3 times and keeping that plus 2. So we got 0 plus 2, which is the 2. Okay, so we have an idea of what a function is. So think of the function as a vending machine. Now next we're going to look at a concept called domain. And a domain is the values for x. In this function you can see there's a variable x. And this x, you can, in this example, you can pick any number for x. Because this function, this operation, you can multiply any number by 3, and with the operations we have multiplication and addition. So you can multiply any number by 3. You can add 2 to any number, but there are some operations we cannot really do. For example, for division, if we do division, we cannot divide any number by 0. So if you want to do 3 divided by 0, it's undefined. And if you do square root of -1, we did talk about in the complex. When we talk about complex numbers, we know it's equal to I. But for functions here, or even in algebra or in calculus class, we usually don't really talk about complex numbers. We only talk about real numbers. If we talk about real numbers, you will have to say undefined, one-node solution. Again, so when we talk about functions, we will not talk about real complex numbers, imaginary numbers. In high-level math, there is a class called a complex analysis that deals with imaginary numbers or complex numbers, but in lower level math, we usually don't talk about imaginary numbers, complex numbers for function. So in this chapter, we assume square root of -1 is undefined, not going to be equal to -1. So it really depends on the subject we're talking about. So in this chapter, when we talk about functions, we only talk about real functions, no complex numbers involved. Okay, so now notice that when we do these two operations, one is division. You cannot divide any number by 0. When the other one is the square root function, you cannot divide, you cannot take square root of a negative number, which we discussed, because you cannot multiply any two numbers to get -1. Positive times positive will still be positive. It's not going to be -1. Negative times negative will still be positive. You cannot get a negative number. And so that's why square root of -1 is undefined. So these two operations will restrict the domain we have. So the function, in previous function, if we talk about domain, the domain will be, for this function, the domain is all numbers, all real numbers, or you can say any number, all real numbers, because you can pick any number for x as an input, you always get an output. But if we have a division function, let's see, suppose we do square root of the function f of x equals 2x over 4x minus 3. So in this case, there is a division involved, not like previously only multiplication, addition involved. Addition, multiplication, you can do these two operations with any numbers. But when you do division, you have to make sure the bottom is not 0. If the bottom is 0, you cannot do it. So I can still draw a vending machine to help you understand this case, but later on, you will not need to draw vending machines anymore to do functions. So let's say if I put a number, let's say 1 in there, and you're going to replace x with 1s. So this is what this machine does. X equals 1, and you're going to replace x with 1. So you're going to get 2 times 1 over 4 times 1 minus 3. So 2 over 4 minus 3, which gives you 2 over 1. That's 2. So you're going to get 2 out. But and you can pick a different number. You're going to get a number out. A different number, you get a number out. But there is a number that you cannot pick. If you pick that number and you try to plug into the function, you are not going to get any answer, which will be undefined. So let's see. Say I'll tell you for now the number is going to be 3/4. So if you try to plug in this number into the function, see what happens. So let's replace this letter x and that letter x with 3/4. See what we're going to get. So we get 2 times 3/4 on the top. On the bottom, we have 4 times 3/4 minus 3. And remember the bottom, this 4 means 4 over 1. So if you reduce that, you're going to get 3 minus 3. That's 0. So you're going to get something, whatever the top is, something on the top divided by 0 on the bottom, which is undefined. It doesn't matter what the top is, 3 or 2 or 1 or even fraction 3/2. You cannot divide anything by 0, so which is undefined. So this number, if you throw this number into the vending machine, nothing will come out. You're not going to get a number. Just like when you go to a vending machine, suppose they only take a dollar bill and you put a $5 bill or a $10 bill, and you're not going to get anything out. Maybe they just put your money back. And so when it's similar, if you put this number into the machine is sort of like get stuck. There's nothing going to come out. In our case, mathematically, because the bottom, when you put the plug number for x, and you're going to get a 0 on the bottom, which is undefined. So, but how did I know it's 3/4? The idea is you just have to think, like we said, in division, the bottom cannot be 0. So you try to think backwards. What number will make the bottom 0? So the bottom, what we have is 4x minus 3. When would this be equal to 0? So we solve this equation, add 3 to both sides, and divide 4 both sides. That tells us x is equal to 3/4. So if we put 3/4 into this function, it's going to be undefined. So you will have to say the domain is going to be x is not equal to 3/4. Okay. Or if you want, you can start from the beginning. Just put it. Okay, the bottom cannot be equal to 0. So you can keep when you solve this inequality not equal to 0, you just solve it like equation. So you find x cannot be 3/4, which means x can be any number, like 1, 2, 3, 4, or -3, -2, but it cannot be 3/4, because if you plug it in, it will make bottom 0, which will become undefined. So similarly, if you have, say, square root of 4x minus 3, you're going to have the same thing. Because when you do square root, it cannot be a negative number. So which means the whatever under the radical sign has to be greater than or equal to 0, because non-negative means greater than or equal to 0. So we solve this inequality, add 3 to both sides, divide 4 both sides. We're going to get x is greater than or equal to 3/4. So you can plug in any number greater than or equal to 3/4, but you cannot plug any number less than 3/4. So for example, if you plug 0 in here, you're going to get -3, which is undefined. Square